This is the Building Automation Monthly Podcast with Phil Zito, episode 82. Hey folks, Phil Zito here, and welcome to episode 82 of the Building Automation Monthly Podcast. And in this episode, I'm going to be talking about 7 tips to master IT networking. Now, when most BAS folks hear the term IT, they start to think of networking first. And granted, there are a ton of other things to IT, but when it comes to the building automation professional, networking is the most common. It's the area we run into the most challenges with IP addressing, subnets, VLANs, routes, default gateways, all these wonderful technology terms that if you've never learned about them before can be a little bit confusing. And add to the mix that you now have pretty much every major manufacturer out there has an IP product line on the market. So what that means is that as a BAS professional, the days of simply relying on DHCP to give you an IP address and call it a day, those days are pretty close to being gone. You know, the world you live in now is where you've got to get comfortable with understanding subnets and what the ramifications of having controls on different subnets means, both to you and to your customer. So I'm going to provide you, just based on my experience, 7 things that I've found to be very beneficial when it comes to working with networks, and specifically when it comes to working with networks from a building automation system technician perspective. So what I don't want you to think, though, before we go into this episode, and this is the last thing I'm going to say really before we dive in, is I don't want you to think that just because I said this is looking at it from a BAS technician perspective, I don't want you to think that this won't apply to sales, or this won't apply to engineers, or this won't apply to facility managers. This will very much apply to each one of you, because each one of you in one way or another is going to be involved in a lot of the areas I'm going to provide tips on. So if you're in those roles, pay attention. There's a lot of really valuable nuggets for you here, especially if you're a salesperson or a consulting engineer and you're just brand new to this kind of IP controls thing and you really want to get up to speed. This episode's really going to get you there. All right, let's dive in. So tip number 1 is understand the first 4 layers of the OSI model. Now, when I'm recording this right now, it's 9:50 at night, and I can't remember if OSI stands for Open Standards Institute, or I can't quite remember what it stands for, what that acronym is. But it doesn't matter. That acronym's a Google away, so you can simply Google OSI. The important thing is the layers. So the OSI model is a 7-layer model, and what a model is basically it helps you kind of visualize how networked communications flow when it comes to applications. And the reason we focus on the first 4 layers are those are the main ones in which you're going to have the most influence, both from a design and an implementation perspective, but you're also going to be doing troubleshooting. You're also going to be answering questions. And when you're doing any of these tasks, it is 9 times out of 10 in one of these 4 layers. So what are the 4 layers of the OSI model? What are the first 4 layers? And the first layer is the physical layer. So oftentimes, whenever I'm troubleshooting something, I like to start with the physical layer. Whenever I'm designing something, I like to start with the physical layer. Whenever I'm explaining something, you get the point. I like to start with the physical layer. The reason why is the physical layer is very binary. And what I mean by that is it's either plugged in or it's not plugged in. It's either a good cable or it's not a good cable. It's either long enough or it's not, or it's too long. One of those things, right? So it's very easy to deal with the physical aspect of the network. Now, there's much more to this, and I could do multiple episodes on signaling and, whether you're using 0 for high or 0 for low, but that would just bore the heck out of you, and it'd be pretty much useless to anything you really need to know. So the important thing is that you just need to know how is the network physically laid out. Now, from here, we go to the data link layer, and this is often your local area network. This is where protocols like Ethernet and BACnet MSTP live. And the main points you want to understand here are things like MAC addressing and address resolution and switching and what all of this stuff means, because quite often when you're troubleshooting stuff, you're going to be dealing with layer 2 data link and layer 3 network layer issues. Those are the main areas that I've found the most issues in. And you want to understand how these things work. You want to understand when you plug in a device to a switch, and that switch has MAC address security enabled on a port, what does that mean? Why does that matter? Those are the kind of things you want to understand. And then next up, you have layer 3. And I know I'm doing a flyby here. I'm like touching everything at about 20,000 feet. I'm not diving super deep because I've got 7 things to go through. But also, each one of these is a topic in itself. So next up, you have networking, right? Networking is where you're going to step outside of your little physical LAN. I want to say VLAN there. It's really late here. I should have drank coffee before this podcast, but hey, you know what? It's all good. So with that being said, a physical LAN is kind of in that data link, and a wide area or a multi-subnet LAN is where you're stepping to in the network. And this is where you start dealing with IP addresses. This is where you start dealing with broadcast domains, multiple broadcast domains, routing, default gateways, all these things. And the important stuff for you to understand here is, do I have my routes? Do I have my BBMDs, my BACnet broadcast management devices set up properly? Do I have my default gateways set up properly? Am I aware of my VLANs? Like, am I putting an IP controller on some network device in another building that's on a separate VLAN and expecting it to communicate with the rest of my BAS systems that are on a different VLAN? I mean, technically, those are separate networks. So how are they going to communicate? Well, you need a route between them. This is why you got to really understand this network layer. And finally, you have the transport layer. And this is becoming really important when you start to deal with, reliable and unreliable protocols. And I could spend a lot on reliable and unreliable protocols, but I've written an article on TCP and the TCP IP stack, and I'll link to that in the show notes of the podcast. That way, I don't spend the entire podcast talking to you about what TCP and UDP are. But essentially, BACnet, right? That's a UDP protocol, and you've got like Modbus TCP, and the difference is how the connection is created, the communication connection, how the communication session's managed, how they deal with reliability of messages, and what that means to traffic and overhead, and what that means to how your message flow works. Troubleshooting a UDP message is a lot different than trying to troubleshoot a TCP message, just because of message flow, of how the communication is executed. Because you see, TCP is a stream. It's a stream of data. Imagine you're hitting a water fountain and that water's streaming out. It's a constant flow. And if you were to slice that flow at any one point in time, you wouldn't get the full picture. So you got to troubleshoot differently. You got to look at the whole stream to understand really what's happening. Whereas with UDP, you have to go and you're looking at these, batch fire and forget messages. They're just these like light blinks. Oh, there's the message. You missed it. And you've got to take a totally different troubleshooting approach when dealing with that. So it's really important that you understand these first 4 layers. Next up, we have tip number 2, and that is that Ethernet and IP are not the same. Oftentimes I'll have people and they'll be like, yeah, I've got an Ethernet system. And I'm like, okay, So what's that mean? And they're like, well, I've got an Ethernet system. I want to remotely connect to it. I got some IP addresses for it. And I'm like, that's not how it works. Ethernet use MAC addresses, and IP addresses they're two totally different layers of the OSI model. They're two totally different things. They're two totally different protocols, the Ethernet protocol versus the IP protocol. And another common misconception is that folks think Ethernet, they think Cat5 cable. But Ethernet could be over fiber. Ethernet could be over a variety of things. It is just a specific protocol. And what you want to understand about Ethernet is that it is a local link protocol, meaning that it is only on that local area network, that physical segment of the network, whereas IP can be across multiple segments. And this is where you're able to get into VLANs. This is where you're able to get into subnetting and routing, things like that. But Ethernet is local network only. And it's really important to understand that, because you don't want to try to troubleshoot Ethernet cross networks. So imagine you're trying to figure out, you're like, oh, I got this MAC address, but the MAC address isn't the same on this other network. And you're like, why is that? Well, because the source and destination MAC address are usually for the local link. So while the source and destination MAC address on one subnet are going to be one thing, they're going to be different on the destination subnet, because now you're talking about the source MAC address being the router or switch for that new subnet. So things are changing. That's why you can't try to troubleshoot a layer 2 or Ethernet protocol the same way you troubleshoot IP. And likewise, you can't design it that way either. You've got to be aware of these differences. Which brings us to tip number 3, and that packets are routed and frames are switched. So if you're once again trying to troubleshoot an Ethernet frame and see why is it traveling across this network boundary, you're not going to be able to troubleshoot that. It's a red herring. I've seen a lot of folks try to chase down Ethernet issues, not understanding that Ethernet is local to that network. What you should be chasing down is the IP issues. You should be trying to figure out what's going on with that. Two totally different troubleshooting approaches. So you really want to think through that. Now, this next tip, we're going to spend a fair amount of time on this, because this is something a lot of folks really struggle with. And that is understanding physical LANs versus virtual LANs. So a physical LAN is often defined as a single broadcast domain. And that single broadcast domain is going to be local to that network. Now, here's the problem with that definition. It's completely wrong, because you can have a broadcast domain via a VLAN that stretches across multiple physical LANs. So oftentimes you'll hear folks say, well, I've got my broadcast and I've got my subnet and and so that's a physical LAN. But it's not a physical LAN. Just because you have a default gateway and a broadcast domain or a broadcast address, and you've got your subnet and your range of IPs, that does not make a physical LAN. A physical LAN is that physical layer 2 switch. Remember, layer 2 is Ethernet switching, and it's that layer 2 switch and the physical devices connected to that layer 2 switch. The physical client devices, not the physical router that's upstream. That's outside that physical LAN. So that is a physical LAN. And if you didn't have IP addresses, and things were like this in the very early days of the internet, where everything would just communicate via Ethernet and everything would be fine. But if you ever have to get out of that physical LAN to another LAN, that's where you need IP addresses, and that's where you need routing. Now, more on routing later and broadcast domains later. But a virtual LAN, what that is a series of physical LANs that logically looks like a single physical LAN. Now, I know that's kind of mind-boggling, because you're like, what? Huh? Well, what that is so you've got these multiple physical LANs, right, with their switches. And using this thing called VLANs or virtual LANs, you're able to assign ports or entire switches to a specific subnet. Now what happens is you use this thing called inter-VLAN routing, where you're able to route between the VLANs. So if there's multiple VLANs on a switch, you're able to route data between them. Now that's an advanced topic, but that then lends us to this other concept of routing, where if I have a VLAN, let's say VLAN 1 on a switch, and I have another VLAN, let's say VLAN 2 on a switch, and what's going on here is that these VLANs are separate subnets, but they may be on the same switch. So you've got two different physical LANs or logical LANs on the same physical LAN. Does that make sense? You following me? All right. So flip that now. Now that because that's an easy concept to see. That's an easy concept to visualize, right? You've got a physical LAN, single switch, bunch of clients, and then you've got these two VLANs that act as two different physical LANs, but they're logical, so they don't really exist. But they're existing in this one physical LAN. A lot of folks can visualize that, but what they can't visualize is multiple physical LANs that are all on the same VLAN, and thus they are one physical LAN logically. They don't physically look like a single LAN, but logically they look like a single LAN. So you really need to understand the difference between those, because that's going to be really important when you're starting to lay out IP controls. You're starting to lay out IP controls across multiple LANs, multiple VLANs, multiple subnets. It's going to be really important you understand these concepts. Now, tip number 5 kind of ties into that, broadcast domains, right? So broadcast domains are really important. So I've heard, I sent out some questions. I was like, what are the benefits of IP controls? Because I really wanted to get some folks who had installed those before. I've played with them a lot. I've played with them in labs. However, I haven't went and installed them. I've designed IP networks, tons of IP networks for all sorts of things, access control, AV, lighting, etc. But I haven't had the privilege, or as some people say, the curse of installing IP-enabled controls yet. I understand the concepts, though. They're all the same. Once you learn star, ring, and bus patterns, that's right, star, ring, and bus. Once you learn those 3 design patterns for IT networks, you can pretty much install any IP-enabled control solution, because that's how they're going to install. But the important thing is to understand ultimately broadcast domains and subnets. And this isn't going to be a subnetting class, but essentially you have 32 bits. These bits are 1, 0. They're either on or off. And you've got what are called network bits and host bits. And basically you count up the network or host bits, and you have that number be the factor of 2. So like if you had 8 host bits, it'd be 2 to the power of 8, and that would be 256. I may be using the wrong math terms here, but you get the point. You have like 8 host bits, so 2 to the power of 8. You have 7 host bits, 2 to the power of 7. So you do that and you get, 256 or 128 addresses that you can have. Well, within that subnet, that is a single broadcast domain, meaning that the broadcasts can travel to that as long as it's on a physical LAN. Because the thing is, broadcasts don't travel across local area network segments. Now, what I've heard from some folks are like, well, I'm going to give a -16, so I have a ton of IP addresses. But here's the problem. First off, you're going to have a route between each physical LAN, because once again, broadcasts don't travel across LANs. So that would be one reason why folks would be like, I'll have a -16, that way everything's on the same subnet, so all my backnet messages, they don't have to have BBMDs. But you do have to have BBMDs because broadcasts don't travel across LAN segments. They're a layer 2 concept, not a layer 3. They're going to have to be routed to other subnets via a BBMD. So that's the first thing. The second thing is, you want to keep your network segments as small as possible. And this really could be a tip of its own. But you want to keep your network segments as small as possible. That way you can troubleshoot them. Because imagine you have a -16, which is like 65,000 IP addresses. Imagine trying to troubleshoot, not that you're ever going to have 65,000 IP controls on a single network, but let's just say in this fantasy world you do, and imagine trying to troubleshoot that and find that proverbial needle in a haystack. It's a lot easier to troubleshoot 32 IP addresses or 128 IP addresses, but 65,000 IP addresses? That's a freaking nightmare. So you want to keep your network segments small. And you keep them small, that's going to keep your broadcast domains isolated, which you're still going to have to use BBMDs anyways for broadcast management of backnet communication. But essentially, the important thing here to understand is just that you can't just be willy-nilly with IP addressing schemes. You've got to understand this stuff. You've got to understand subnetting. You've got to understand how you approach these things. Which brings us to tip number 6, which is subnets and default gateways. So I've used the term subnet a lot here without defining it. I've used the term VLAN and LAN. A subnet, all that is a portion of a networking IP address pool. So you have public IP addresses. These are routable across the network, meaning that you can communicate across the internet, things like that. And then you have private IP address ranges, and these are routable on the private networks, but not routable to the internet, meaning that you have to use some sort of technology like network address translation to translate the two. And I'm not going to go into that. That's a whole nother topic in itself as well. But the important thing here is a subnet is a slice of a IP address pool. When they invented IP addresses, they had like 2 billion in the entire IP address pool. They didn't think folks were going to use more than that. Well, folks are definitely using more than that. I think they say there's like 100 or 50 different IP-enabled devices in the average home. So, I mean, you imagine you got 300 million people in the U.S. Each one of those people is in a home, maybe several people to a home, but you get the point. You could easily eat up all those IP addresses in just in the homes. So that's why you have private IP addresses, because these private IP addresses are essentially addresses that don't exist outside to the greater interwebs. And what happens is you have network address translation, which basically says, oh, your public IP is this, well, here's your private IP. And it matches them up. Well, subnetting is where you go and you slice a piece of private IP addressing for yourself, and you get a default gateway. That's where all traffic that doesn't know where to go on the network, it goes there. And then that's where your routes exist, and your routes are basically like, here's how you get to network B from network A. You use this route, and it tells you. And that is through the default gateway. Now that brings us to our last tip, which is tip number 7, trunking and quality of service. And it's really important to understand these concepts, and they matter quite a bit. You will hear me sometimes in the podcast say uplink ports or trunk ports. And what I'm talking about are these connections between switches and routers, connections between networking devices. They aren't used for client messaging. They're used to communicate between networking devices. And when I say networking devices, I'm not talking NICs, network interface cards. Those are client devices, right? So these connections between the switch and the router, that would be a trunk port, not an access port, not an access link, but a trunk link, trunk ports. And it's across these trunks that all of your VLANs will communicate. So you can have multiple VLANs communicating across a trunk. And I've actually seen quite a few issues with building automation systems where the building automation system had an issue in that its traffic wasn't getting prioritized over other traffic, and this was causing what are called quality of service issues. Now, quality of service issues are when a network goes to communicate and it has more traffic than it has capacity. What happens is the network will look at the traffic and its tag and will understand the priority of that traffic. Normally video is given like the highest priority. And if that traffic is communicating and the BAS is communicating, that traffic's going to win out and the BAS packets are going to be dropped. Now, normally this isn't such a big deal. This happens all the time. You lose a packet here or there. It's not the end of the world. It's when you lose entire, multiple seconds worth of traffic or even minutes worth of traffic due to maybe someone streaming 4K video across the same trunk link as your BAS. Now, in the past, we've been very fortunate in that IT departments have pretty much sheltered us from this. But now with all these IP controls, we're having to deal with a lot of switching. And the reality is that most of these IT switches that we're going to hang our controls on are going to have other devices on it, which means these other devices are going to have trunk links. And I've even seen some architectures where they talk about on a ring architecture having like IP cameras and access control and all sorts of stuff. And the problem with that is, let's say you have a 4K camera. Well, that thing could theoretically eat up all the bandwidth of your network link. And then what does that mean? Well, that means your BAS traffic's not going to get through. And if that gets bad enough, you could have essentially a denial of service where you're not getting data from your IP controls. Like I said, this wasn't such a big deal when IT was handling all the networking and all we had to do was request static IP addresses. Now we've actually got to think of network layouts, especially with IP-enabled controls or IP-enabled smart equipment. You need to think about how do you lay out your network? What switches are you connecting to? What information is traveling up? What trunk links? What's your quality of service? How are these things being designed? Because if you don't think about that, then you're going to run into some serious major issues. So there you have it, folks. These were just some raw thoughts I jotted down based on questions I've been asked and just things I've experienced during my time in the field. I wanted to take a couple minutes and just kind of impart some knowledge on you. Wanted to give you something that was a little more hands-on, kind of these are the gotchas, these are the things you should look out for. Now I realize each one of these tips could have been a podcast episode in itself, so here's what I really recommend you do. I recommend you look at the topic that is most relevant to you and then go and research that topic. Go and figure out what do you need to know about that topic? What would you like to know about that topic? And dig deep into that. That's kind of how I approached learning IT. And if you haven't, if you haven't gone and done that before, or you just don't feel comfortable going in and doing learning on your own, trying to figure it out, or maybe you just want to save the time. Maybe time's really important to you. You're one of those people who realize as you're getting older, kind of like I am, that you can make more money, but you can't get your time back. Well, in that case, I really encourage you to check out my new Information Technology for Building Automation Professionals online video training course. This course is designed to teach you everything you need to know about IT as a building automation professional. No matter if you're in sales, engineering, consulting, you're a tech, you're a project manager, it's going to get you where you need to know in regards to information technology. So I really encourage you to check that out. I will include a link to the sales page for that course so you can read more about that course in the show notes. And speaking of that, the show notes can be found at buildingautomationmonthly.com/82. Once again, that is buildingautomationmonthly.com/82. I really look forward to your comments and your feedback and any specific topics you'd like me to cover going forward. I'm going to be focused on networking and things like that for the next couple episodes. It's just a very timely topic right now. In the next episode, we're going to dive into IP controls. What are they? What are the benefits? What are the cons? How do they work? What do you need to be aware of? Those kind of things. All right, folks, that's it for tonight. I appreciate you listening once again. Thanks a ton. And if you have any questions, drop them in the comments below the podcast, which once again will be at buildingautomationmonthly.com/82. Thanks a ton. Keep up the hard work. Continue to push through, to grow in your knowledge every day, and you will be amazed where you end up a year from now. Talk to you all again next week. Take care.